Hello friends, welcome to another session of Transistor 2. In last session we discussed on the transistor, diodes and transistor, comparison between the diode and transistor, how the transistor construct, what are the function of three terminal of transistor, that is the emitter, base and collector, how they are doping. In this session we are discussing the types of transistor and their working. Usually, silicon is used for making the transistor because of their high voltage rating, greater current, and less temperature sensitivity. The emitter base section kept in forward bias constitutes the base current, which flow through the region of base. The magnitude of the base current is very small. The base current causes the electrons to move into the collector region or create a hole in the base region. As we know, the base of the transistor is very thin and lightly doped, because of which it has less number of electrons as compared to the emitter. The few of electrons of the emitter combined with the holes of the base region and remaining electrons move towards the collector region and constitutes the collector current. Thus we can say that the large collector current is obtained by varying the base region. So some recombination takes place here. So the collector current set up by excess of electrons from emitter to collector side, and the recombination here is done toward the base. When the emitter junction is in forward bias and the collector junction is in reverse bias, then it is said to be active region. The transistor has two junctions which can be biased in different ways. The different working conditions of the transistor has been done. So this is the emitter base collector or base region, emitter base region, and this side is the collector base region. So by making various working conduction of the transistor, we form the conditions with their emitter junction and collector junction, then what type of region is operated. Here is the simple tabular to describe the transistor operation condition. In first column there is a condition, and second column is emitter junction bias. Here is the collector junction bias and is the region of operation. If both the conditions means both the emitter base junction and collector base junction is connected in forward bias and reverse bias respectively, then what happens? So the first condition, that is the FR, means emitter junction is in forward bias while collector junction is in reverse bias. The transistor operates in the active region. But if we are changing the condition that both the junctions, that is the emitter junction bias and collector junction, are in forward bias, then the transistor operates in the saturation. And when both the junctions, emitter base junction and collector junction, are in reverse bias, then the transistor operates in the cutoff. And if we take the vice versa of the first condition, that is the reverse bias to the emitter junction and forward bias to the collector junction, then the transistor operates in inverted form. Now in the forward reverse case. The emitter base junction is connected to in forward bias and the collector base junction is connected in reverse bias. The transistor in the active region, the transistor is in the active region and the collector current is depend on the emitter current. The transistor which operates in this region is used for amplification. In forward bias, both the junction is in forward bias, the transistor is in saturation and the collector current becomes independent of the base current. The transistor acts like a closed switch. When both the transistors are in both the connections are in reverse bias, so both the current are in reverse bias. The emitter does not supply the majority charge carriers to the base and carrier currents are not collected by the collector. Thus the transistor acts like a closed switch. In reverse forward, the emitter base junction is in reverse bias and the collector base junction is kept in forward bias, as the collector is lightly doped as compared to the emitter junction. It does not supply the majority charge carrier to the base. Hence, poor transistor action is achieved. As we know, there are two types of transistor. One is the NPN and another is the PNP. The first of all, when we are considering the transistor as an NPN, the transistor in which one p-type material is placed between two n-type material is known as NPN transistor. The NPN transistor amplifies the weak signal enter into the base and produce strong amplified signals at the collector end. In NPN transistor, the direction of movement of an electron is from the emitter to collector region, due to which the current constitutes in the transistor. Such type of transistor is mostly used in the circuit because majority charge carriers are electrons, which are high mobility as compared to the hole. How the construction of NPN transistor? The NPN transistor has two diodes connected back to back. The diode on the left side is called as the emitter base diode, and the diodes on the left side are called right side are called collector base diode. These names are given as per the name of their terminals. Again, the NPN transistor has three terminals, namely emitter, base and collector. The middle section of the NPN is lightly doped and it is most important factor of the working of the transistor. The emitter is moderately doped and the collector is heavily doped. And another type, that is the PNP transistor. The construction of PNP transistor is connected to the emitter base junction is connected in forward bias and the collector base junction is connected in reverse bias. The emitter which is connected in forward bias attract the electrons toward the battery and hence constitutes the current to flow from emitter to collector. The base of transistor is always kept positive with respect to the collector so that the hole from the collector junction cannot enter into the base, and the base emitter is kept in forward, due to which the holes from the emitter region enter into the base and then into the collector region by crossing the depletion region. This is the circuit of NPN transistor. This is the circuit diagram of NPN transistor. The collector and the base, here is the collector and the base. Circuit is connected in reverse bias, while the emitter and base circuit is connected in forward bias. The collector is always connected to the positive supply and the base is in negative supply for controlling on and off states of the transistor. So the flow of charges this direction. So the collector current is set up. Similarly, for the PNP circuit, here the same procedure is there, but simply charges are in opposite direction. So actual working of NPN transistor. In this circuit diagram, forward bias is applied across the emitter base junction, this side, and the reverse bias is applied across the collector base junction. The VEB, that is the forward bias voltage, is small compared to the reverse bias voltage VCB. The emitter of the NPN transistor is heavily doped. When the forward bias is applied across the emitter, the majority charge carriers move from this side towards the base. This causes the emitter current IE, the electron enters into the p-type material and combined with the holes. The base of NPN transistor is lightly doped, due to which only few of electrons are combined and remaining constitute the base current, that is the referred as IB. These base currents enter into the collector region. The reverse bias potential of the collector region applies the high attractive force on the electrons reaching toward the collector junction. Thus, attract or collect the electrons at the collector. The whole of the emitter current is entered into the base. Thus, we can say that the emitter current is the sum of collector and base current. So this is the simple function working of the NPN transistor. Now we are discussing about the PNP transistor. Here the emitter base junction is connected to the forward bias, due to which the emitter pushes the holes in the base. These holes constitute the emitter current. When these electrons move into the N-type semiconductor material or base, they combine with electrons. The base of the transistor is thin, very lightly doped. Hence only few electrons combined with the electrons and the remaining are moved toward the collector space charge layer, hence develops the base current. The collector base region is connected in the reverse bias. The holes which collects around the depletion region when coming under the impact of negative polarity collected or attracted by the collector, this develops the collector current. The complete emitter current flows through the collector current IC. So what is the difference between NPN and PNP transistor? One of the major difference between the NPN and PNP transistor is that in the NPN transistor, the current flow between collector to emitter when the positive supply is given to the base, whereas in PNP transistor, the charge carrier flows from the emitter to the collector when negative supply is given to the base. The NPN and PNP transistors are differentiated in next slide by comparison. The NPN and PNP both are the bipolar junction transistor. It is the current controlling device and mainly used for switching and amplifying the signals. Mostly the NPN transistor is used in the current circuit because in NPN transistor the conduction current is mainly by electrons, while in the PNP transistor the conduction current is because of the holes. As the electrons are more mobile, the NPN has high conduction. The latter PNP and NPN show the voltage requires by the emitter, collector and base of the junction transistor. The NPN and PNP transistor both are made up of different material due to which current develops in them and also differs. Sometimes when the voltage applied across the emitter, the electron cross the base junction and reach to the collector region. This happens because the base of the NPN and PNP transistor is very thin and lightly doped. Here it is simple comparison chart. As per the definition, the transistor in which two N-type layer are separated by one P-type layer. In PNP transistor, two blocks of P-type semiconductors are separated by one thin block of N-type semiconductor. The direction of current is in NPN transistor collector to emitter. In PNP transistor it is emitter to collector. When it is turned on, when electron enters into the base in NPN transistor, whereas in PNP transistor when holes enter into the base. Inside current of NPN transistor develops because of varying position of the electrons. In PNP region, the inside current originate because of varying position of holes. Outside current develops because of the flow of holes in NPN transistor, whereas in PNP transistor, current develops because of the flow of electrons. Majority charge carriers are in NPN transistors are electron, whereas holes are the majority charge carriers are in PNP transistor. Switching time of NPN transistor is faster, whereas PNP transistor is slower. Minority charge carriers in the NPN transistors are hole, whereas in electrons are minority charge carriers in PNP transistor. Positive charge given to the collector terminal in NPN transistor, whereas positive voltage is given to the emitter terminal in PNP transistor. Forward bias is connected in both emitter base junction and emitter junction of PNPN and NPN transistor, whereas the reverse bias is provided to the both of the collector base junctions of NPN and PNP transistor. The small current flows in NPN from emitter to base. In PNP also their base to emitter, and ground signal is very low in NPN transistor, whereas high signal ground signal is in PNP transistor. So this is the simple comparison of the transistor and the working of PNP and NPN transistor. In next session, we discuss on the connections of the transistor, how it forms. That is the common base connection, common emitter connection, and common collector connection. So this configuration discuss in next session. So thank you very much for watching this video.